Okay, question number 27. The siren of a moving police car emits a sound wave with a frequency of 440 Hz. So the frequency F0 is equal to 440 Hz. Okay, this is the actual frequency. Observer hears a sound of frequency 494 Hz. F dash is equal to 494 Hz. What's happening over here? The frequency is increasing, which means what? The vehicle is moving towards him. Okay, the speed of the sound in air C is equal to 340 meter per second. Okay, what could be the speed and direction of the movement of the car? Definitely he is moving towards the observer, right? So therefore away from the observer is gone, away from the observer is gone. Either of these two should be correct. But you know the values are very close. We should be very careful while doing this. What's the formula? F dash should be equal to F naught into C minus V observer minus C minus V source. Okay. Remember, observer at the top, source at the bottom. Okay. It is something like you are moving in a car. The source is van and V observer should be at the top. Okay. Now towards it, I remember it like this. So therefore, this should be 494 is equal to 440 multiplied by observer 0. So C divided by, what is C? C for C is 340. Let me substitute that also. 340 divided by 340 minus V source. I do not know what is source over here, right? I need to find out this. So when I do this, I get this as 494 divided by 440 into 340 is equal to 1 by 340 minus Vs. Let us calculate what is this value here. So if you calculate this, this should be 494 divided by 440 is equal to so much, divided by 340 is equal to 0.0033. Okay, so therefore this should now be equal to 0.0033 here. In other words, we don't have space over here. So therefore 340 minus Vs should be equal to 1 by 0033. Okay, let us calculate what is this value. If I take the reciprocal of this one, I get the answer 302. This should be 302. So Vs should be equal to 340 minus 302, which should be 10 minus 2 is 8, 4 minus 0 is, so here just 338 meter per second. So which is the right answer? Right answer is 37 meter per second directly towards the observer. Answer is B. Okay.